So keep solving our physics subject GRE 87. So 87 says you have a force, and I ask you about the total energy. So this problem is simple that because you know the force, so basically you need to find the potential, because the total energy is kick any energy plus potential. So dV over dr is minus the force, so V of r is basically k to r to the cube. There's a minus sign. Okay, so then we need to find the velocity. So basically F equals to ma. So we have k to r to the 3 equals to n v squared over r. So mv squared is k over r to the cube to every r squared. So half of this half. So you have k over 2r squared plus v of r. So the total energy is 0. Total energy is 0. So the answer is C. The answer is C. AT, that is a parallel capacitor, is connected to a battery. V naught between the plates, and Q naught is the charge, and E naught is the electric field, and D naught is the displacement vector. So we have V naught, Q naught, E naught, D naught for a parallel capacitor. And after that, there is some dielectric constant object which fill in, but the battery is fixed, then it disconnected. Okay, so basically we have this, and then we have this. So this is K epsilon naught. So from here, the battery is the same. So V naught. So the E naught is V naught divided by D. Because basically this is the definition of the potential. So the E naught is fixed. However, the C is equal to epsilon naught divided by epsilon naught times A divided by D in the left hand side. And for this one is epsilon K epsilon naught divided by D. Okay. And the Q is equal to CV. So this is CV naught. So this one is this C. I call it C tilde V naught. So basically it is K Q naught. So this is larger. QF is larger, and this is VF, EF. Okay, how about D? So remember, D is proportional to sigma. D is just sigma in a parallel plate. So D 0 less than DF. So A is not correct, B is not correct, C is not correct, D is not correct. Answer is E. Answer is E. Okay, so 1889 is also a standard question. If you pick an infinite barrier for the harmonic oscillator, then when will change? So basically, since there's an infinite barrier here, so at x equals to 0, the phi should be 0. This tells you that phi is odd function. So the answer is only the odd function remains. I should write all the other functions remain. So the energy is just like the same before, but n is odd. So the answer is E. Only the odd value for n will present. Okay, so number 90 that the spacing of the rotation energy levels for the hydrogen molecule. Unfortunately, I don't have any good way to solve this problem. Basically, this is some energy scale you have to memorize. So basically, the rotation scale is this one, and the vibration scale is this one. Okay. So you need to remember it's two. Okay. So the answer is this one. This one. So answer is B. Answer is B. You need to remember. So there's no way that you can guess or compute. So 91, the particle decay, weak interaction, because the first one is pi. What? Pi minus is lepton. Definitely not. So lepton has mu1 electrons, not pi minus. So pi minus is, I guess, is if I remember correctly, is the pi. This pion is not a lepton. Okay. And the second one is this has spin 0. So this particle is baryon. So baryon has spin half. So B is not correct. And the no neutrino is produced in a decay. So what? No neutrino has not produced in a decay. Does not mean it must be a weak interaction. So D, angular momentum always conserve. Angular momentum always conserve in the standard model interactions. So the remaining is E. So you usually this type of standard model question is difficult, that you need to remember at least some basic properties of the weak interaction.